Chapter 4, Number 7. A hot air balloon is drifting in level flight due east at 2.5 meters per second due to a light wind. Pilot suddenly notices the balloon must gain 24 meters of altitude in order to clear the top of a hill 120 meters to the east. How much time does the pilot have to make the altitude change without crashing into the hill? Good. B. What minimum constant upward acceleration is needed in order to clear the hill? And C. What are the horizontal and vertical velocities of the balloon's velocity at that instant when it clears the top of the hill? So, as always, we should probably draw a picture as usual. So, here is our balloon with a little gondola, and it's traveling with an initial speed in the x, which is 2.5 meters per second. And then the idea is that, let's do this, that around here, all of a sudden, the hill rises, or whatever. Whoops, I'm not quite right. And this height is 24 meters at a distance, of 120 meters. So that's our setup. And what we want to know is how long do we have to get higher than that point, and then what acceleration gets us there, and what are the velocities. So part A, we want the time, but we can tell that we have a delta x. We need delta x. We are going to travel 120 meters, and we want to find what time. That's what we're looking for here. So if we take, as we usually do, we take this, actually, to be really honest, we'll take this as our origin. So this is x equals 0, and this is y equals 0. So then we end up, we'll say, well, since there's no horizontal acceleration, we have x is x0 plus v0 xt. So we have 120 meters is 0 meters, because we start at 0, plus 2.5 meters per second times t, or t is 120 meters over 2.5 meters per second, which will give us seconds, which is nice. And we end up at 48 seconds, which has the right number of sig figs, so that was nice and convenient. All right, and then for part B, in green. So for part B, now we have that it has to rise to a height, right, where it has the vertical coordinate will obey y equals y0 plus v0 yt plus 1/2 ayt squared, and we have some conveniences. We'll say we start off at 0 height. It's not height above the ground, but height above our initial point, so that's fine. And it had no vertical velocity to begin with. So I really end up with that y is just 1/2 ayt squared. And now we know that we have to go up 24 meters in 48 seconds. So we put that in here, and we find that ay is 2 times 24 over 48 seconds squared. And we see again our units work out nicely. It's going to be meters per second. And the numbers are chosen kind of goofily, but they will work out to be 1 over 48, or an acceleration of 0.0208 meters per second squared, which we should really round to only 2 digits, or 0.021 meters per second square. Relatively gentle upward acceleration. Finally, for part C, we can just get the velocity components just by remembering that Vx is going to be V0x, because there's no acceleration horizontal, so that's going to be 2.5 meters per second. And Vy is going to be V0y plus AYT, but again, this is 0. So we're left with just 0.021 meters per second squared times 48 seconds, which is 1.008 meters per second, which is to 2 digits 1.0 meters per second. By the way, we can see that sort of in an alternate universe where we had noticed that the acceleration was 1/48th meter per second square times 48 seconds. We would get exactly 1 meter per second, because Walker picked kind of weird numbers.